Hey everyone, this is Miss Valentine, and you are watching the 17.1 Notes presentation on energy resources and fossil fuels. Our last unit was all about climate change, and one of the reasons we have so much climate change or accelerated climate change in the past 150 years is because of our use of fossil fuels. So this first section is going to really focus on the resources that we use and the industry that we've developed and how fossil fuels have really fueled that development, fueled our industrial revolution. So, a fossil fuel is just any non renewable energy resource that is formed from the remains of organisms that lived long ago. So, fossils is why they're called fossil fuels. They're made from not necessarily dinosaurs that we think of, but usually from plants and also very small microscopic organisms in the ocean. So, even though they're called fossil fuels, it's generally not like the bone fossils that you think of. Most of the energy that we use today still comes from fossil fuels because we've set our entire country and our infrastructure up on a system that uses fossil fuels. We're looking to move away from that in the coming decades in order to reduce the climate change that is causing us so much problems now. We use those fossil fuels to run our cars, ships, planes, and factories, and then to produce electricity, which is the way that most of us consume our energy at home and around the world. So, fossil fuels are central to our modern industrial life, but there's two major problems with it. The first one is that the supply of fossil fuels is limited. Now, we still have plenty for the next 100 or 200 years, and actually, if we don't care about the environmental pollution at all, it might even last more than 300 years. But the problem is that a lot of the fossil fuel use involves environmental consequences that we have to then deal with. So even though it might not run out for quite a while, for several centuries for us, the environmental problems like climate change are so big that it's worth it for us to move away from them before the environmental consequences become too great. In the 21st century, and beyond, societies will continue to look for alternatives to fossil fuels. So the hydrogen power, the wind power, solar power, those things that we'll discuss actually in future sections. And then also on becoming more efficient in their use of all energy. When you're more efficient, it just means that you get more energy out of the fuels that you are using. And we'll talk a lot more about that in later sections as well. So the main uses of fuel that we see in industrialized countries and around the world, transportation is a major one. So that would be the gasoline that you put in your car. Manufacturing is a major use of energy. Heating and cooling buildings is actually the biggest expense on a residential level. So what you pay for at home, most of that energy is coming from heating and cooling. And then generating electricity to run our machines and our appliances, our refrigerators, our computers. So that electricity is just one of the four major purposes. There are other smaller things like cooking and heating smaller areas, maybe, but the major uses are on heating, cooling, manufacturing, and transportation. So each fuel can give you a certain benefit, and fuels are evaluated based on how much energy content is in that fuel. So there's actually not the same amount of energy in every type. The cost for getting it out, the cost for giving it to consumers, the availability of that fuel out in the environment, and then also in geographic regions. So certain things are available in parts of the United States that aren't available in other places. And then you also have to consider the safety and the byproducts or the waste that comes from the different energy types. Electricity is our main source of industrialized society. If you think about it, when your power goes out, it is like everything stops. Your entire world stops when there's no electricity available. It is the most convenient way for us to get energy because the fuel is converted from like oil or coal. You don't have to burn that directly. You just get it in your wall socket. You can plug something in and it works. Electricity is also really easy to transport. I shouldn't say easy, but we've developed an infrastructure where it's easy to transport quickly over long distances. So you can have a power plant an hour and a half away, which is how close our closest coal plant is, and that electricity can be sent all the way here very quickly. So it makes it a really good source of power for the appliances that we have in our homes, especially. The problem with electricity, though, is that it's difficult to store. We don't have these giant batteries that are storing it up. Everything that all the lights and everything that you have on around you right now is being generated right now at about an hour and a half away at a power plant. And so every light that you have on right now, everything that you see that's electric, that's working right now, that energy is being burned as we speak, either coal or natural gas, most likely some solar, some wind, but most likely it's one of the fossil fuel sources. So if we could store that energy, it actually would make solar and wind power much better because you don't have to wait for the sun to be shining or the wind to be blowing in order to have energy. It could store up that energy. But unfortunately, electricity is just difficult to store. Here we are at our first pit stop. Pause the video while you answer these two questions. What are the two main problems with using fossil fuels for energy production? And then why are fossil fuels often converted to electricity? Again, pause the video while you answer the questions. So, how is electricity generated or how is electricity made? You use a device called an electric generator, and this is something that creates electrical energy from mechanical energy. So, think of a mechanic is someone who deals with moving parts. Mechanical energy is just the energy of motion. So, you're taking mechanical energy or moving energy and you're turning it into an electric current that you would send through your electric wires. And this is done using a electrically conductive material, usually a metal, with magnetic components. So magnetism and electricity often go together. If you ever take physics, you'll find that out. But the electric generator is used to turn moving energy into electrical energy. And we'll talk about how that actually works. Here is a picture. Oh, there we go. We'll look at that picture in just a moment. I think you have that on your notes packet. But what happens is for a commercial electric generator, it's taking the movement of a turbine, which is just a spinning wheel. And that changes the movement into electrical energy, like I said in the last slide. Now, the turbine is, again, that wheel, and it's spinning the generator, which has a magnet in it, and that turns it into the electricity. Whatever fuel that you're using to spin that wheel, to produce steam to spin that wheel, does not matter. So the steam being released from boiling water is what's spinning the wheel, which spins the generator. Whether that's heated by coal, by gas, or by the fission of uranium and nuclear power plants does not matter. That steam is just designed to spin a turbine. Now, in the case of a wind turbine, which is what we see as windmills, the turbine is spun by the force of the wind, so there is no steam needed. And then in the case of hydroelectric power or dams, you're using the power of falling water to spin the turbine in order to generate the electricity. So how you spin the turbine does not matter so much. You just need to make sure that you can get that mechanical energy going in order to produce the electric current. So the picture in the next slide and the one that you have on your notes is showing how a coal-powered plant works. But basically, so in the case of a coal power plant, you are creating steam, and that steam is being used to turn the turbine. So whether you're using coal or natural gas or fission uranium, your goal is to generate steam and turn this turbine. Like I said, in the case of wind power, you can turn this turbine just by the power of the wind. And in the case of hydroelectric, you can turn this turbine just by the power of falling water. So turning that turbine is the key thing in order to get this generator to produce an electrical current, and magnets are involved. All right, so here is a pit stop question related to what we were just talking about with the turbines. What causes a turbine to spin? So pause the video while you answer this question, and you could talk about any of the non-renewable resources or the renewable resources that I mentioned that would cause a turbine to spin. Pause the video again while you answer the question. World energy use is different in different parts of the world. So everything that we do, the food we eat, the clothes we wear, requires energy in order for us to use it. And there's huge differences in the developing world versus the developed world. In the developed world where we live in the United States, Australia, Europe, they use a lot more energy than people in developing countries. Now, developing countries do want to have more energy use, and that's why it's important for us to come up with alternative ways to produce energy than fossil fuels. They are adapting a lifestyle that's very similar to developed countries, and we want to make sure that they're able to do so without all the environmental consequences that go along with using fossil fuels. This picture here just kind of shows you the energy use of the world. This is a picture of the Earth at night, a satellite image here. So you can see in the eastern United States, we have a huge amount of energy. And then in Eastern Europe, or I'm sorry, Western Europe, you see a lot of energy use as well. There's also a lot in India and China, particularly because the population is large, and here's Japan here. But the developed world is definitely where you have most of your energy use. Australia as well down here, most of their population is actually on their eastern coast, but you see a lot here as well. So it just shows that energy use is not evenly distributed around the world. Some parts of the world use a lot more than others. In the United States, we use more energy per person than any other country except for Canada and the United Arab Emirates. Canada is because of the excessive heating uh, use of fuel. And then in the UAE, they have a lot of cooling. And then they also have a lot of energy just available to them. So they use a lot of energy as a result of that. The US uses more than 25% of its energy just for transportation, though. So if you look here, the transportation sector is huge. So it's not just transporting us personally, but also transporting all the goods and the food and the things that we need around around our area. So we have lots of goods in the United States. We also have a large land mass to transport it over. And so it makes sense that we use over a quarter of our energy just to transport goods and people. So fossil fuel deposits form in different ways, and it all depends on what the land was like when the fossil fuels formed. So again, millions of years ago, we're looking at geologic history. In Texas and Alaska, there's lots of oil, but very little in Maine. And then in the eastern United States, we have a lot more coal. So even in closer to our region, in the eastern part of Ohio, you'll see coal deposits as well. So all of that has to do with what happened in those areas at the time that those fossil fuels were formed. What's the geologic processes that took place? This is a map showing the coal, oil, and natural gas deposits around the United States. So you can see here we've got lots of coal, and like I said, we have some coal right here. And then natural gas is actually pretty abundant in the eastern US as well. Along here is the Appalachian Mountain Chain, and that's part of the reason why those things were formed where they were. You also have a large amount of coal here in the Great Plains states and up here in Montana. So it's found in some parts of the world, but not, or some parts of the US, but not in others. All right, here is our next pit stop. Pause the video while you answer the question, which countries use the most energy worldwide? All right, so let's talk about how fossil fuels are formed. They were made in different conditions under different geologic circumstances. So coal comes from the remains of plants that once lived in swamps hundreds of millions of years ago. Those plants in those swamps became buried with sediment because ocean levels rose, bringing in dirt and sediment. And then when they fall, that sediment just settles down. And over time, you get this buildup of that material. So again, this is over the process takes place over millions of years. Layers of that sediment or that material gets compressed or squished together along with the plant remains, and then you take heat and pressure with the earth, usually comes from mountain forming, like in the Appalachian Mountains, and that causes the coal to form. So again, this is many hundreds of millions of years ago that this took place, that this process took place. And so it's hard to make it. It's a long-term, non-renewable energy resource. The way I remember that coal is formed in this way is that coal is like a solid material. And so you think of land as a solid material. So coal is formed on land, usually in swampland. On the other hand, oil and natural gas are formed in the ocean. So tiny marine organisms, the word marine just means ocean. So tiny little ocean creatures. They when they die, they sink to the bottom of the ocean floor and then get buried by sediment. So, a good way to remember how oil and natural gas are formed is to think of the fact that they are liquid, or gas is a gas, but the oil is a liquid and the ocean is liquid. So, that shows or helps you remember that the oil and natural gas is formed in the ocean under the water. The molecules over time, though, can migrate or move as a liquid into porous rock formations. So basically, just rocks that have holes in them. And now those rocks contain those, and that's what we're usually drilling for when we're looking for oil in land. We're looking for the gas and the oil molecules that migrated or moved into those holy rock formations on land. All right, here we are with our pit stop, and I gave you some ways to remember where each of these form. Where does coal come from? What is it formed from? And then what is natural gas formed from? Pause the video while you answer the question. One of the major things that we have found with coal is that it has a very damaging effect on the environment. The environmental effects have become too much for us to deal with. So even though coal is cheap, we have lots of readily available coal. Part of the problem is the mining is very bad, and then also burning coal creates a lot of air pollution as well. So unfortunately, underground mining um, is not very safe, and oftentimes the coal companies will move to just remove the entire top of a mountain just to reach a coal deposit rather than going underground now. And unfortunately, that completely wrecks the ecosystem. It can damage the water on the surface, the rivers and lakes around the area. And we try to find the most clean burning coal deposits in order to reduce the amount of coal mining that we have to do in an area. And by clean burning, I mean it doesn't have the same toxic chemicals in it when you burn that coal. This is showing a mountaintop removal operation. I think this might be in West Virginia, but you can see it completely just strips the top of the mountain and damages the ecosystems. And then any rain that falls in this will bring some of the pollution from that coal into the local waterways. So it's very damaging. The process of mining is very damaging. Coal is also a major air pollution problem. Sulfur, which is found in all coal, can be a contributor to acid precipitation or acid rain. If you look at the leaves in this picture, one of them is a healthy one and the other one has just been rained on by acid rain. So high sulfur coal, it will cause this acid rain to happen. And so we have come up with technology, we call it clean burning coal technology, to reduce the amount of sulfur that gets into the atmosphere when you burn it. And companies will stop even looking at certain coal mines because they have high sulfur coal. So even though we have all this abundant fuel, we really don't use it as much, or we're moving away from using it as much because it is so dirty because of the materials that come out and create air pollution. Petroleum is just another word for oil. So petroleum, it's a liquid mixture and it has lots of hydrocarbon molecules in it. We call it crude oil when you dig it right out of the ground. And then you take that crude oil and you do what's called refining. So you might hear about oil refineries around the US. And when they are hit by bad weather, our gas prices go up because those refineries are taking that crude oil and they're turning it into different things. So they turn it into gasoline, they turn it into methane, propane. Plastics are actually made out of petroleum. So even like petroleum jelly, that is made out of oil as well. So petroleum accounts for 45% of our commercial energy use. So oil, again, another word for petroleum, is a major source for a lot of the energy use we have. And then the rest of those products go into making plastics and other chemicals that we use in our products. Oil is a major source of pollutants. Um, Petroleum fuel itself can cause air pollution, so smog and other health problems contribute to the air pollution. Carbon dioxide released from burning petroleum fuels contributes to global warming, though I would say that's also the case with coal. So any fossil fuel is releasing a lot of carbon dioxide. Um, Oil spills from tanker ships are another big problem of oil use. However, even those big oil tankers that cause huge destruction when they spill, the most oil pollution comes from our leaking cars. Every time you see a pile of oil in the Walmart parking lot, that oil is eventually going to wash into our local waterways and then out to the ocean. So all of our combined small little oil leaks on land contribute the most to oil pollution, more so than even those huge tanker ships that crash off the coast sometimes, and you hear about those. So oil is subject to environmental regulation. We've also come up with technologies that reduce the amount of air pollution as well. So there is government's regulation, at least in developed countries like the United States, to try and prevent that pollution from damaging the environment around people. Unfortunately, though, it still isn't as strict as we'd like to see it be, and so there still is a lot of environmental degradation as a result of using fossil fuels. The developing nations that are building their economies on fossil fuels have even less regulations for environmental protection. And so it's really important that we, as a developed country, help them with their non fossil fuel energy resources so they can build their economy on those. And so the entire environment is not damaged by all of our collective use of fossil fuels. Here we are at our next pit stop. Where does most oil pollution come from? Pause the video while you answer the question. Natural gas is a much cleaner fossil fuel than coal and oil. And so countries like the United States have really invested in natural gas technology to reduce the amount of carbon dioxide released into the atmosphere and the amount of pollution. So about 20% of our non-renewable energy comes from natural gas worldwide. And like I said, it's much less polluting than other fossil fuels. And vehicles that run on natural gas require fewer pollution controls. So there is natural gas vehicles. I think the UPS brand uses natural gas vehicles, and then you'll sometimes see buses that run on natural gas. Those vehicles might be less expensive because you don't require as much equipment to control the pollution. Electric power plants can also use natural gas instead of oil or coal. So you'll see a lot of natural gas power plants being constructed in the United States nowadays because we're trying to replace our old coal and oil powered plants from previous generations. So natural gas, it is better than the other fossil fuels. However, it is still a fossil fuel and it is still contributing to global warming. The fossil fuel supply currently is around 90% of the energy used in developed countries. So that's a huge portion. The demand for energy resources is increasing. And so we should see an increase in the cost of fossil fuels. But we do have a lot of government money that goes into keeping our energy costs low. And unfortunately, that also causes people to use more energy than they would if it actually reflected the true cost that it is to create that energy. So planning for the energy we'll use in the future is important because it takes a lot of years for a new source of energy to become part of our infrastructure, like wind or solar. So those things take some time to ramp up. So we really need to plan for the future in order to make those a bigger part of our future energy use, energy infrastructure. So recent technologies have really increased our natural oil and gas production in the United States, especially from shale rock. And that process is called hydraulic fracturing or fracking. And we'll be watching a video this week about fracking because it is a big topic in the United States. It's a great technology that has made us more independent from other countries that produce fossil fuels, but then it's also very environmentally damaging as well. So you have to weigh the pros and cons of that. We also have a lot of oil reserves in the ocean, but we've got to remember that it's expensive to drill in the ocean, and there's also the potential for big environmental damage when you drill for oil in the ocean. All right, here we are at our summary page. Check out this damn oil. Nasty stuff when it gets stuck to cement. Read through your notes again and write a 5-sentence summary about this section.